What's up, gangsters? This is going to be a super nerdy little adventure that is part fusion design and part 3D printing. So, let's talk about chains. If you watch my channel, you know that I don't build a lot of armor or vehicles, but one of my favorite things that I think adds a nice touch of realism and authenticity is to include a chain, especially when it's got nicely scaled hooks on it. I think it's just fun and cool. And I know, look, that statement is going to outrage some of you guys who are going to be like, bro, you should never use chains for towing. They're like so dangerous and stuff. Yeah, look, I get it. I understand. But that's the kind of thing, honestly, that gets said by people, model makers, who have never worked around heavy equipment, or if they have, they just never encountered the thing in question and they just go straight to denial on the basis that no crew chief, whatever. Anyway, look, I get that a nice bright orange nylon tow strap is always the best and the safest thing. But those aren't always available. And they definitely were not available in 1944 and probably not even in 1984. And the truth is that tow cables are just not fun, especially at the 1-inch diameter that's pretty common on armored vehicles. And I know that a lot of model makers don't understand this because you'll see the way that they're depicted is as if they're soft. Like they drape over things. And I can tell you from direct experience as a farm boy that these cables are not soft. They do not drape, especially at small diameters, small bend radius, at least over a short distance. And look, even though they're technically called wire rope, yeah, they are stiff and unruly, especially when they get a little bit frayed, because one of those stray wire fibers will stab you in the thumb right through your leather work glove. Ask me how I know. So the point being is that it's pretty common to have chains in the back of your farm truck. You know, maybe you need to tow a vehicle down the road and there's really not that much resistance. Or you need to just give it a little bit of a tug to get it out of the mud. Or you're in a hurry and you need to get a tree that's fallen down in the road so that your armored column can move to the fighting position. And look, dudes are always going to grab the thing that's quickest and most efficient regardless of what the alleged rules are. Or, and this is a situation I've definitely seen and done, you've got something like a hydraulic cylinder that's failed and the thing that it's supposed to lift won't lift anymore. So you have to jack it up manually and then basically tie it in place with a chain so that you can get to the barn and do a repair. So look, point is chains are super handy and they actually get used a lot. And so it makes perfect sense to include them in a scale model, but the problem is that good metal chain is pretty hard to find. I've got some in my collection of detail parts and I hoard that stuff like it's made out of platinum. And I can't even remember the name of the place I got it. But the thing is, the links are the correct oval shape for, what's most commonly used for a field type chain. There's a bunch of different link styles for chains. But what there's not is like jewelry chain. And you can always tell when a model maker uses some jewelry chain because it's got, links that overlap or they're twisted and they just look ridiculous. So I thought, well, if you can't find real metal chain, could you 3D print some? And that's what started the chain challenge. And so that's what this episode is about, is seeing what it takes to design and print a scale model chain. Okay, so if I'm going to print a chain, obviously I need a file to print from, and I wanted to make my own. And I don't want to turn this into like a detailed lesson on using Fusion 360, but I do kind of want to show you how I did it and what my rationale was. So this is the file. You can see I've just created a length here, and it's pre-supported. And the reason that I pre-supported it is because doing this manually where you've got to put 2 supports on each link, yeah, that is going to get old in a hurry, and Lychee, Chitabox, whatever your slicer of choice is not going to make that easy on you. Whereas Fusion or any CAD package has tools that make generating a pattern of supports like this just as easy as it makes generating the links themselves. So that's why the supports are already in there. But let's go back to the very beginning of this file and just quickly step through each part of it and explain what I'm doing here. So I know that I want each part of the chain, link, whatever, to have opposing 45-degree orientation. So the first thing I need to do is create a sketch plane, and that's what that is. And this will make sense here in a minute. So my first sketch is going to be for the shape of the link itself. Now, you might be wondering, well, how do I decide on that? How do I decide what those dimensions are going to be? Well, you can just sort of make it up if you want to, make it look about right, and you might be fine. But because this chain is going to be scaled down, and I wanted it to be what would represent a 4-inch link at 1/48 scale, I wanted my numbers to be pretty good. So what I did is, this is really cool. All right, this is kind of a little bonus feature. One of my favorite things is McMaster-Carr. McMaster-Carr is the industrial supply Bible. Like back in the day when this thing used to only exist on paper, it was a big yellow book that you would sometimes see in machine shops that's like 2,500 pages long, and it has like everything. And now, because this is the 21st century, all of that wonderfulness is on the web, and they make it super easy to search. So let's just put in, we want chain. So let's just put in chain. All right. And right away we see chain. So we'll go to that, and we can see there's all kinds of chain here. All different link styles, chain not for lifting, chain for lifting. So let's just go with this, a grade 80 chain that's for lifting. Now all of this stuff is standardized because, there was lots of testing and engineering, and we figured out how big chains needed to be in order to support certain amounts of load. So this stuff is all pretty well documented, and you can see right here, all right, that if we want to look at the length and the width and the thickness, that all of those numbers are right here on the McMaster-Carr order page. So if I want one that's going to be 4 inches long, well, I don't even have a big enough one here. Well, 2.44 inches on the inside. It has a 0.8 inch wire, so that's 2.44 plus that times 2, that's basically 4 inches. And if you take 4 inches and convert it to metric and scale it down, let's just assume that that's about the right number. I won't swear to it. But nonetheless, you can see how this works. And you can also see that with this being a nominal 3/4 inch chain, look at how much it weighs per foot, 5.8 pounds per foot. So if this chain is 10 feet long, that's 60 pounds because you got some hooks on there. 20 feet long, which is a good length for a chain. That's 120, 130 pounds of chain. That is a honking big, thick chain. So, point being is that you can get all of these numbers to create your design and go and put them here on your sketch. All right. So let's back out of that, and you'll see that what this is going to be is this is going to be the sketch that we will use for a sweep feature. In other words, we're going to use this as like the racetrack, and we're going to run a profile all the way around that to create the shape of the link. And we need a plane to do that, so we'll create a plane on path, and then we'll do a sketch on that, and that sketch is going to be the cross section of the link itself, and then we'll do the sweep feature, and there we go. And you can see that it's oriented at a 45-degree angle to horizontal, and we're going to go ahead and repeat all of that to get the next link in the chain. See what I did there? And there you go. So that's the beginning of the pattern that I want to build to create this whole chain. Now I need to do some more things to get set up. I need to put some axes along these cylindrical features because I'm going to put some sketch planes through those, and those planes are going to be what I will draw the sketch on that I will use to create each of the supports. All right. And so let's take a look at that. So this is my support sketch, and yeah, I'm cheating. This is the final version of all this, but nonetheless, this is the way it looks after I've already done all the stuff I'm about to show you. But hey, look, it's 2024. We can do time travel. Anyway, so what this is this is a cross section that I'm going to revolve around an axis in order to create the support feature. So it just goes like that. There's the first one. And then there's the second one. And now I need another set of supports for this part of the chain. And so we'll do that. There's one there, and there's one there. And this now becomes more clear why I wanted to orient these links at exactly 45 degrees, because that puts those supports directly in line with each other, and both of them can be, both of the ones on this side can be on one sketch plane. Same thing over here. So I'm just trying to be efficient. Now let me show you something else that's kind of a cool part of using CAD like this. I have obviously two links. And if I wanted to change the size of this chain, I would, in theory, have to go and modify both sets of sketches, right? Because I have a sketch for the path on both of them and a sketch for the profile on both of them. But when I go in here, all right, see these dimensions have designations. This is dimension 4. D4 is 2 millimeters. D5 is 1.2 millimeters. And if I go here to this sketch, notice that these dimensions say f of x equals 2, f of x equals 1.2. That's because I just told it, instead of putting a number in there, this is dimension D4. So all I ever have to do to change, and the same thing with this dimension over here, and the same thing with the dimension here that controls the wire size. So if I change this, let's change it to something that's easy to see. If I change it here, and I regenerate, now look, both links are adjusted because I've put that parameter in there, and it'll control both of them. And that just makes the model much more easy to modify if I want to make different sizes of chain. And I did the same sort of things with the dimensions that control the size and shape of these supports as well. So if I decided, as I did, that I need to modify these, then all I have to do is go to the first sketch and change those, and then the second set of supports will also get rolled up in that. So that gets me the basic pattern of the thing, and now all I need is a path, and that's going to be this sketch right here. And now I'm going to do what's called a pattern on path. And I do that by selecting this and selecting this option right here, pattern on path. And what it's going to do is it's going to take this set of features and repeat those at whatever interval I tell it all the way along this continuous path. And there we go. Then all it needs is a base underneath it. And boom, there is my part. All I have to do is go in here to save as mesh and export the STL file. Okay, so yes, I tried. This is my first one, and yeah, as you can see, things did not go well. It is dangling from the plate, and I'm going to need to take that out of there and clean it up and try again. So here's a closer look at that, and as I suspected, whoops, the supports failed, and that's kind of what I thought was going to happen there. I think what I probably did is I haven't printed this thing or tried to print it. I've never successfully printed it, but it's been like a year since I tried, and I suspect that these support tips are still at 0.1 millimeters in diameter. So let's go have a look. Okay, so the first thing that I want to do to try and get this thing to print, obviously, is make it stay attached to the supports. And I looked at this, and as I thought, my support tips were only 0.1 millimeters in diameter where they attach to the to the part, and that clearly was not strong enough. So when we zoom in on that, you can see how I'm controlling the diameter of the point where it attaches to the chain link. So I've got it where it's buried completely in the chain link, but I have a driven dimension right here that shows what its diameter will be at that surface. So if I change this number right here to 0.1, you can see what happens there. The angle stays the same, everything stays the same, but this number gets bigger. So that's how I control that. Now you might say, well, but you got to do that on every single one. No, that's why I did it as a pattern. All right, and as you can see, it's a pattern of 2, and so this one over here, I just used an equal constraint so that this line segment is equal to this one, and if I change that to 0.1 again, see, they both change. So that makes it pretty efficient. So with it changed to where it's now 0.2 millimeters in diameter right there, I'm going to go print that and see how it does. Okay, so here's number 2. And yeah, this is exciting because this is the farthest that I've ever gotten. And I don't know if it's going to come off. I suspect that it's not going to work even if I get it off the plate, because it looks like the links are too fat. In other words, even though I designed them with clearance and the way that they're supported, each link is actually separate from its neighbor so that they don't touch, and in theory they would all come off the plate and be free to move about. It looks like these are a little fat, which is normal because as a rule everything you 3D print is going to be a little oversized, at least with resin printers, or if you ever happen to do any SLS, selective laser sintering printing. And there are ways to compensate for that. In fact, I am running there's a compensation setting in Lychee for the Mars 4 Ultra, and what it does is it basically just cuts some pixels off the outside of every cross section. And I experimented with that a bit to get rid of the elephant's foot effect, where the burn-in layers, because they're so hot, end up expanding out equally on all sides. And I have the compensation set, and it works for that elephant's foot. And you can see that's pretty nice. That base has pretty nice edges. I don't have a chamfer on the bottom of it or anything, but I don't have it set for the actual layers because if you're thinking ahead, you probably realize that it's going to shrink the parts, and that might not be what you want. And so I don't know if it's, I haven't experimented with it on actual layers. And so anyway, I don't know. So I don't know how I'm going to get this off of here without looking at it super close up and without jostling the camera. So I apologize. I will try. What I'm going to try to do is cut underneath some of these supports and see if I can separate those. Yeah, and as I thought, you can see. So I haven't cured this, and I'm not going to bother with it because what I thought was going to happen, sorry, this is very difficult. Anyway, these links are basically glued together, at least a little bit, and I don't know, these supports are 0.2 millimeters, and I don't know, they may be, I might be able to get away with something in between 0.1 and 0.2. I don't know, jury's still out. I'm gonna clearly have to chip away at this. Maybe I will go ahead and go cure this because it's very rubbery, and it might actually come off here easier if I cure it. Okay, I'm back. I cured it for a couple of minutes, and I'm going to give it another try. I should also mention that when I washed this, I ran it for only 2 minutes. And I don't know, some people might think that that's too long. I don't know. I normally, because I have a 2-stage washing system, and the first one runs for like 5 minutes, and I'm kind of lazy with it, so I usually just let it go because, I want that first one to really get as much resin off as possible. And then the second one is, I can time it. And anyway, different resins have different sensitivity to isopropyl alcohol, which is what I use. And this resin, I should have mentioned it right off the bat. Maybe I did, I don't know. Anyway, this is the new Frozen RPG, which is supposed to be able to maintain good detail while staying more flexible. I guess RPG must stand for role-playing games, and so it's intended for the kind of minis that are used for that, and may take a lot of handling and abuse, and so it needs to be a little more flexible, but also, you want good detail for little swords and horns and teeth and things. So anyway, Alex Clark, who is a very good model maker and a good designer and a good printer, has been using this resin a lot on his ridiculously cool and detailed 1/72nd scale tank parts. And he's a big fan, so I asked him about it, and decided to test it out. So anyway, I could ramble on while I peel this whole thing off of here, but I'm gonna just get after it and fast forward. So yeah, this is way further than I've ever gotten before, but still not successful, because these links have to be separate. But I'm getting closer. Okay, so I got closer on version 2.0, but there were really two issues. One was, as you saw, the links weren't really free to pivot, and the other issue is that it was actually harder than I expected it to be to get it off of the supports. So I thought, well, I need to come back in here and take a look at the file itself and make sure that I've got enough space between the links. And if I do, then maybe I'm going to go tweak it at the printer. So I got to looking around at this thing, and I noticed something that I missed before, and you guys may have seen it when I was showing you the clip about how I changed the support diameter. When I did that, look at how close the support got to the links right there. These shorter ones are fine, but these up here, not good, because while it's definitely going to stick to the link, it's also going to stick to the chain itself, which is not good. So I got to solve that problem. I don't know, that might solve both problems, because there may be a chunk of this that's gluing these two links together, and I really need to change just one variable at a time, right? So when I look at this, the question is that enough distance between here and here? I mean, it's obviously like 0.1 millimeters, which is the bare minimum, so it might not be enough. When you look between here, that's more like 0.2 millimeters, and that's probably okay. So I don't know, but the first thing I got to fix is this. Okay, so what I ultimately decided to do was just make these supports as tall and skinny as possible by just going in here and massaging the sketch until I had what I wanted. It's not quite as efficient as it was because I don't have these common dimensions, but it's okay. It's still not that hard to manipulate, and right now what I'm trying to do is just get to where I can pass the chain challenge. So that's what I've got. Now, I still don't have a huge amount of space between those, whoops, getting a little crazy there. Let's try and not do too much drunk panning and orbiting. Okay, so there's still not a huge amount of space between these supports and these links. So, but I also did another thing. I can control the thickness of the link on all of them pretty easily by just going back to this sketch right here. And that's the one dimension that controls the diameter of the link wire, if you will. And so I just dropped that from 0.4 to 0.35, and we'll see if that's enough. I don't know. We'll see. Maybe, maybe not. But it also gave me more clearance between each link, and that certainly won't hurt things. And, you know, it looks a little more kind of properly proportioned now anyway. So we'll see how it goes. Okay, so here we go, version 3.0. And I went ahead and cut loose the links at the very tip to make it a little easier so you guys wouldn't have to watch that. And I don't know if you can see this or not. Sorry, I'm already banging into the camera. But these links are free floating. So this is exciting. So question is, can I grab it and pull it off? It's doing it, but it's giving me some resistance, so I'm trying to be really careful. And I think the next thing is going to be to experiment with reducing the diameter of the support tips again.
Ooh, look at that. If I don't pull straight up, it comes off a lot easier. I think it might actually happen. There it is. Got the whole chain.
Okay, so as always, I could not resist taking one more whack to see if I could really refine this, because the goal is to be able to, you know, unzip the whole thing without stopping. And so I knew that 0.1 millimeter tips on the supports was not going to hold, so I tried 1.5 or 0.15. Since 0.2 was a little tougher than I thought it should be. And I also made them a little taller. But that was, let's see which one of these it is. That was a sort of partial fail. Somewhere over here. Yeah, so nope, that's not it. It was... yeah, I think it was this one. Anyway, it about half stayed connected, but the rest of it didn't print right. So I went to 1.7. Anyway, so there we go. And I made the supports now are 2.5 millimeters tall, just to give them a little more flex. So let's get the end loose here and see what we got. I don't like the way this first set of links is acting kind of sticky. Of course, I can't find my tweezers. So, here we go. I hate to say anything, I don't want to jinx it. Ah! It didn't break. I just lost my grip on it. But of course that was terrifying for a second. There it is. The whole thing. Almost in one shot if I hadn't lost my grip. Okay, so there you go. Like I said up front, rated N for nerdy. But, you know, hopefully there's some stuff in there that you might find useful, even if you don't necessarily want to print your own workable resin chain. I mean, that pattern on path thing, that's a pretty powerful tool in Fusion that you can use for things like, you know, a string of rivets or whatever. So anyway, hopefully it's useful and maybe a little entertaining. And as always, I appreciate you watching. Much love.